Good afternoon, everyone. Hope you can hear me. Thank you for joining us today for this webinar, which we have titled as How Virtual Twins Can Help Rethink Products, Processes, and Business Models to Realize Sustainable Innovations. So, just to give a brief introduction, organizations currently are actively working towards sustainability targets, navigating challenges along the way. These challenges also present the biggest business opportunities for all industries today. Some of the challenges are how product designs and material selections are the most suitable ones, which processes have the lowest consumption of land and water resources, which manufacturing and supplier strategy has the best carbon footprint. So in this webinar, our experts will try to answer these questions and also showcase how solutions from Dassault Systems help in optimize manufacturing processes, reduce waste, and achieve sustainable goals. Before handing it over to our experts, I would like to begin the webinar by giving a short introduction about our company, EDS Technologies. EDS Technologies was incorporated in 1994 to focus on providing PLM solutions, implementation, and support. We are the largest technology solutions provider in India and also platinum partner to Dassault Systems. We have served more than 2,000 customers across India and operate across 9 locations, with our headquarters being at Bangalore. We also have strategic partnerships with world leaders like EOS for additive manufacturing requirements, Human Solutions for ergonomic solutions, Technia for ensuring product data quality. For military simulation and training needs of aerospace and defense industry, we have partnered with MAC for visual simulation solutions. We also have strategic partnership with Esri for GIS requirements and Synopsys for EDA solutions. We have a dedicated sales, support, marketing, and customer satisfaction teams to address PLM business and support requirements. In today's webinar, we are joined by Mr. Srikumar Maganti and Mr. Murali Krishna Kumar. So a brief introduction about our speakers today. Mr. Srikumar Maganti is the Senior General Manager, Technical at EDS Technologies. He carries a rich experience of more than 20 years in the PLM domain and works on CATIA, Innovia, and the 3D Experience platform, which involves technical support, corporate trainings, and customer relationship. He has worked on-site for numerous prestigious clients to provide the best customer experience. At EDS Technologies, he is responsible for the 3D Experience brand and also holds various global certifications from Dassault Systems. Our second speaker for the day is Mr. Murali. Mr. Murali Krishna Kumar started his career as a project associate in manufacturing engineering. He has a master's degree in computer integrated manufacturing and has worked in various manufacturing greenfield projects as manufacturing engineer. He has more than 12 years of rich industrial experience working for automotive companies and is currently working as senior solution consultant at EDS Technologies for our digital manufacturing solution, Delmia.
Thank you, Abhay. Today, let us start the agenda. Let us start with the agenda of the day. We are going to talk about sustainable innovations using virtual twin. So we start with business challenges in sustainable innovation path first, then sustainability for design, engineering, and manufacturing, followed by a virtual twin model and life cycle assessment, which is the most critical component of this, and then data intelligence and data-driven decisions for sustainability, followed by the summary and the customer references. To start with the business challenges in sustainable innovation path. So why we are looking for sustainable innovation is that we are looking for long-term survival of the companies or organizations with the sustainable products, which will also ensure that there is a minimized environmental footprint and carbon emissions. So this is something which is also something related to our society and the way of living. So looking at this sustainable innovation path, if you look at the challenges, I'll start with few questions with respect to design activities. Like, I mean, already if you take Rio Summit or later United Nations Summit, you look at all the countries pledging for net zero carbon emissions by 2030, 2050 goals. So how to reduce this product's environmental footprint is the first question. And then if I make a new design which is more eco-friendly, uh, at what point of time the assessment is taken care in terms of life cycle phases. And then if I look at multiple components of an assembly, where is the main part of the environmental footprint is coming from? Suppose if I go for design alternatives, can we ensure no pollution shifting? Because the pollution shifting is happening from air to soil to water. Can I avoid that by looking into alternative designs? So these are some of the questions which are increasingly becoming prominent, and most of the countries have already committed to these environmental goals across multiple declarations. And these are the important questionnaire which is going to drive our sustainable product development as well as manufacturing. Then looking into revealing the meaningful insights. So which life cycle phase has the highest environmental contribution? Is it at the product development level, service level, or is it at raw material level, or is it at the transportation level? So we need to look at all the meaningful insights. So these are some of the important challenges that we face. Then monitor and forecasting. Typically, how might evolve the environmental footprint of the product or process? So we need to look at the metrics convergence and ensure that all the environmental targets are met in due course of time. So these are some of the challenges which are faced by the industry, and these are becoming more prominent over the years. So if I look at, there is a study which was done by Accenture and Dassault Systems together. They have come out with a complete case study and a white paper as well. So these are the 5 important prominent industries which are highly likely to be impacted in terms of sustainability quantification. So you look at construction cities, we are trying to reduce the energy consumption in the buildings, apartments by 30 to 80%. So that is the most important aspect. Sorry. And then consumer packaging, goods, and home and lifestyle. So this is what something which is relevant to society. So a lot of packaging goods are coming in online as well as offline. So how do you reduce the 80% of the impact, taking care of the design from the initial stage? Then transportation mobility, yes, we are looking at the accelerating the time to market. Life sciences, because pharmaceutical manufacturing always brings in lots of pollution and waste, and also the resource consumption. How do I reduce this so that I can have a sustainable drug making coming out of life sciences industry? Then high tech and electronics, there is a lot of electronic waste which is coming out of these industries. Today, India is the largest mobile manufacturer. Just imagine the kind of electronic waste coming out of these mobile manufacturing companies. So we need to look at some of these industry segments and then how it is really impacting them and how we can actually reduce this. If you look at the overall market, it is like a sustainability sustainable product development is of like $1.3 trillion market by reducing the 7.5 gallon tons of carbon dioxide emissions. So I will just run through a small video explaining about some of those customer references. So here, if you look at, the virtual twin is a digital representation of the real-time world, and you can imagine, design, and test anything using the virtual twin concepts. So we are bringing this virtual twins, we are enriching this sustainable product development through virtual twin. So this is applicable to all the industry segments. If you take a architecture and construction, we are looking at low carbon autonomous this thing, and then we want to reduce the 70% water consumption, 40% household waste. Then we are looking at air flows between the buildings. We are also looking at the energy usage and recycling methods. So again, looking at CPG industry, yes, a lot of we are looking at the materials basically. One of our customer, Amcor, they have started working on the light plastic bottles. They are able to reduce this plastic consumption by almost 50%. So similarly, it is also applicable to transportation mobility industry. So here also we are looking at battery cell manufacturing, battery packs, and then how it is going to impact in terms of manufacturing, because there is a carbon footprint involved even for battery cell and battery pack manufacturing. So again, we need to look at how we can reduce the faster time to accelerate the faster time to market. So in this case, again, we have some of the customers using the sustainable product development in this case. Similarly, Sanofi is one of those customers who have worked on the chemical reduction by almost 94%. This is something which is possible only through sustainable product development goals. So every industry is vying for sustainable innovation, sustainable product development, and then they are looking for a circular economy. Basically, when I say circular economy, basically you're looking at the waste management and recyclability of the materials. So, and also recycled products can be also reutilized. So that is something which is going to be part of circular economy. So the virtual twin model is going to provide a big benefit for the industry. Here we can look at reduction of almost 7.5 gallon tons of carbon dioxide emissions across the globe. So this is the brief introduction on the industry segments I would like to highlight. So by having this virtual twin embedding with the life cycle assessment into product design, development, and manufacturing, we can actually drive the decisions in this every industry segment. Similarly, we can we can drive collaborative innovation. We can achieve the sustainability targets. We can optimize the operations. We can meet the sustainability targets, comply with the regulation standards, and also we can make a difference for the social living. So this is something which you can expect having this sustainable goals and sustainable targets assessment followed by interpretations. So if you look at consumer packaged goods industry, I mean, there is 80% of the product's environmental impact is actually determined during the initial stage of the design itself. So if I am taking care of design, looking into some of those important categories, the environmental footprint as well as weight, overall weight management, then I can definitely look at the better design, better sustainable design for the future. So it is all the more important for all the product development organizations to look at meeting the sustainability targets even in the initial stage of design itself. So this is going to be a greater impact for the future, because once you are able to bring in sustainability goals at the design phase till the manufacturing, you are able to see the major difference coming in terms of sustainable design. At the same time, you are also contributing to the society from the environment impact perspective. So the next one topic is like on the sustainability for design, engineering, and manufacturing, because this is the core area for us in terms of life cycle assessment. So enforcing sustainable goals throughout the design phases and project management, respecting the weight targets and also the environmental commitments with decision-making analytics. We should be able to analyze the current design process. We should be able to measure the impact, environmental footprint in terms of points, and we should be able to measure them accurately. At the same time, we should be able to interpret the results and make the alternative designs, which are going to be very important from the sustainable product development point of view. So if you look at some of those metrics on 3D Experience platform, what Dassault Systems offers, so there is environmental footprint and performance. One is carbon dioxide emissions, acidification and land usage, water usage. Then you have photochemical ozone creation and so on. There are so many environmental methods which have come up, even in Europe as well as North American countries, even in Dutch, Germany. You find a lot of regulations which have already come up very well, which I'm going to explain in the coming slides. So this environmental footprint has to be calculated in precise, and then we need to look at the performance also in terms of weight, overall weight. So these are the two important key metrics which are going to determine the sustainability metrics and also the sustainable product design. I mean, if you look at the the major impact, it is on the day-to-day utilization. So consumer packaging goods industry is the one which is going to be highly impacted. Almost like 80% of the environmental footprint impact you can see in that industry. Then followed by life sciences, because it adds to lots of pollution and waste management, and also the carbon emissions. So that's the answer for you. So let's move forward. With who are the stakeholders in the organization. So there is a sustainability manager who will actually set the goals. We are going to set the business target definitions for the sustainability product development. So sustainability manager is going to set the goals against which all the measurements are taken care. And then we have eco design engineer who brings the 3D product design, say from CATIA, and then he is able to associate the physical CAD data model with the parameters coming from the environmental footprint. Then the assessment happens. There is a weight manager who is looking at the overall weight of the component, center of gravity, inertia matrix, and also the distribution curves. So he'll be assessing the weight definition for each and every component in the assembly. And then there is a sustainability analyst, basically, who looks into the overall analytics, basically. So he's the man actually critical for the business decisions, because based on the analysis only you are able to see the data analytics only you are able to predict what needs to be changed. You are able to change the material, or you are able to change the design in terms of the thickness, or also in terms of topology and shape optimization, or it can be something relevant to packaging and also transportation and so on. So there data analytics is a critical factor here. So this is done by sustainability analyst. So these are some of the roles you can expect in the organization, whichever is the organization driving the sustainability initiative, right? Then comes the eco invent database. So this is one of the most consistent and transparent lifecycle inventory database which is available today, which is also embedded into 3D experience platform of Dassault Systems. This will provide the the wide range of human activities. So there are almost like 450 human activities which are highlighted, because environmental footprint is calculated from the human activities perspective. So how the human activities are going to impact the environment, that is the most critical aspect here. Then comes, it will also have the 5 environmental methods with respect to Europe or North America or Dutch or German. And then it also has all the processes with respect to manufacturing. So this is the database which is embedded into 3D Experience platform, wherein you will be able to pick up the regulation standards and also pick up the parameters which is meant for assessing. So these are some of those global environmental methods which are certified and which are the regulatory bodies across the globe. If you look at EF 3.0, which is developed by European Commission, so they are a single global body who are actually looking into environmental footprint based on the 16 metrics. And then we also have TRACI V2.1, which is based from America, US Environmental Protection Agency. It has also defined sustainability metrics from the point of climatic change, ozone depletion, acidification, smog and eutrophication, and so on. Similarly, we have IPCC standards coming from United Nations. Then we have RISIP standards coming again from Dutch and national. So we have several environmental methods. Now these are all embedded into eco invent database, which is also part of this 3D experience platform. So I will take an example of the European Commission standards, where they have highlighted the metrics, sustainability metrics: carbon dioxide emissions, water usage, land usage, ecotoxicity. Then we are looking at the water, marine eutrophication, and soil, again terrestrial eutrophication. We are looking at acidification, carcinogenic effects, respiratory effects. We should also look at the damage for the human. So there are certain metrics with respect to human damage that is also considered as a part of the sustainability metrics: photochemical ozone creation, fossil depletion, and so on. So we are looking at all possibilities here, and these are the key metrics for the European Commission. Whoever is actually bringing the sustainable product development and sustainable product design in Europe, they will be following these standards. So I will take a simple case study in this webinar using a model coming from a BIMI projector. Basically, this is meant for watching, projecting your video onto the wall, and then you are able to, run through the television or videos or any other visuals. So BIMI projector is a simple model which is a combination of mechanical components. It has sheet metal components, plastic components. It also has a battery cell, pack, and it also has some of those raw materials coming from polymers, like we have ABS, acrylonitrile butadiene styrene copolymers. So we are taking the example of BIMI projector, which has a combination of multiple range of materials. Now I need to assess each and every component which is coming from this, from the perspective of environmental footprint against the specific standard or environmental method, and then I should be able to assess whether my product is meeting the environmental regulations or not. So this is an example I would like to take up in this session. Before that, I would like to highlight something about life cycle assessment. So when I say product development, we start with the product design, raw materials extraction and processing, product manufacturing, packaging and distribution, product usage and consumption, and followed by end of life or disposal or the new life, recyclability. So we are looking at all aspects of the product, right from the production starting stage of design till end of life. So all these things come in as factors as a part of life cycle assessment. Again, it is impacting the land, air, water in the environment, which is going to be an important assessment for us. So if you look at the 4 major principles of assessment, it has to be holistic, that is on a product, on an assembly line, and then on a supply chain or on a service. We need to look at the holistic product development, and also the environment factor will come in at every level, at a product design level, assembly manufacturing level, supply chain level, as well as service level. Similarly, when I say quantitative, we are looking at the measurable metrics, that is how much amount of carbon emissions are coming out of the product, how much is the energy consumption for creating this particular product, and then whether it is, I have shown about the 16 metrics, right? So it has to be quantitative in terms of assessment. Then multiple set of criteria coming from environmental regulation bodies, then followed by normalized. That means basically you are going to the ISO standards of 14040 and 14044 standards. So life cycle assessment is framed by ISO standards, which needs to be followed by all the product development companies. So it also should ensure that your decision is not leading to you are trying to avoid the decisions leading to pollution shifting. So that is the most critical thing as a part of assessment. So we start with the sustainable goal and scope definition, followed by inventory analysis, then the impact assessment, and the interpretation of the results leading towards alternative designs. So this is something which we are going to do in this example. So as a part of 3D experience platform, we have a business target definition, value definition, eco-design assessment, and then alternative designs. This is how we are going to work on. So this is example where we have something like ABS material coming in for the frame. We have injection molding, the plastic components. We have again non-ferrous metals, then battery cell production, which is lithium ion NMC 811 standard. Then we have 8-watt speaker production for BIMI, which is also important aspect here. So we need to look at each and every individual component, assess them against the measurable metrics, and then perform the analytics. So I'm going to run through this example here through a small video. So CATIA has eco design engineer role. Basically, this is going to help in terms of connecting with the environmental footprint calculations. So the physical CAD data from CATIA is associated with the definition of the standards. So in the business standards, we are setting up this carbon emissions, overall carbon emissions, say 53 kg against say 47 kg like that. So we have an input which we need to bring in here. We need to look at type of manufacturing. Again, we need to look at the energy consumption, electricity. We also need to look at again which kind of material it is. So we are going to pick up some of those human activities with respect to the entire process, product design as well as manufacturing, transportation. We are going to pick up all those metrics from the regular standards, and we are picking up in this case European Commission's EF 3.0 standards, environmental methods, to assess this particular component product against these some of these measurable metrics. So we are looking at carbon dioxide emissions, water usage, land usage, energy consumption, then acidification, eutrophication, terrestrial as well as marine. All these things will come in, and also packaging and transportation. So when I'm sending this particular product to a different location, definitely I need to look at all possibilities of carbon dioxide emissions. So we are going to put all those metrics and calculate here, and we're going to assess this particular assembly, right? And then we can look at the analytics. So we are, if you look at here, we have analyzed all the sub assemblies: batteries, ABS plastic, then projectors, speaker, front part fabrics, and then electrical, black parts, and then back shell, and also the button classing. So this is how we are going to do the energy consumption and also carbon dioxide emissions with each individual sub-assembly or component category. So once we complete this assessment, then we can actually measure against the environmental methods, regulations basically, to say whether it is eco-friendly or not. So CATIA Eco Designer will help you to assess this way and say that yes, this is the particular model which is carbon eco-friendly, which has lesser carbon dioxide emissions coming in and meeting the environmental standards. So this is how we are going to perform on this. I have some more examples, but looking at the paucity of time, if it is feasible, I will showcase those case studies also at the last part of the session. So here in this case, we are assessing raw materials, we are assessing the battery cell, we are injection molded plastics, we are assessing ABS, we are assessing the individual components. Finally, we are looking at the overall weight of the assembly and also the carbon footprint calculations. And based on this, we are able to assess and provide alternative designs which are meeting the requirements. So for analytics purpose, we have something called sustainability analytics role, sustainability analytics analyst role, wherein you are able to assess the performance of the product against the environmental footprint in this example. So here the analyst is going to look at the overall environmental footprint and what is the objective to meet in terms of overall number of points, say 6,000 points here, and it is almost 700 points extra. So how to reduce this overall footprint? Now let us see the alternative designs. So we will go to the module level, battery, speaker, and so on and so, and which is that component where I need to reduce the carbon footprint so that my overall summary of the environmental footprint points will come down. So we are going to work on the alternative designs. We may use recyclable plastics, we may use some other materials which is going to reduce the carbon dioxide emissions in this case. So based on that, we can reassess again against these environmental methods and find out whether my design is really sustainable or not. So here we have metrics can be visualized here. We can actually do the carbon dioxide emissions prediction. It's a kind of predictive analytics which is brought in by 3D Experience platform, and using this you are able to assess and predict also like how much amount of carbon dioxide emissions going to be for the individual component as well as overall assembly. So now again, if I change the material, how it is going to look like? Recycled plastic, then alternatives comparison also happens, trade-off studies will happen, and based on the trade-off studies, again, how it is going to, define. So here in this case, we have comparison of two different scenarios for the alternate designs. BME Classic with the recycled plastic and BME Classic with ABS plastic. So recycled plastic is actually meeting the requirements with respect to carbon dioxide emissions. So that is how we can actually look at the alternative designs which is meeting the requirements, and then progress with the eco-friendly designs. So these are the two important roles that we run through 3D Experience platform to do the sustainability product development, which is going to meet the environmental regulations and standards. So in summary, I can highlight like this 3D Experience platform has embedded eco-invent database, which has got more than 400 human activities and thousands of processes as a part of the libraries. And we can actually establish the digital continuum between engineering and life cycle assessment. We can enforce the sustainable goals to drive the sustainable innovation. We can reveal, assess, and introspect in everything in 3D. And also we can do multiple trade-off studies using the sustainable analyst role, followed by we can leverage the company's IP and accelerate the innovation. And also we can monitor the sustainability matrix evaluation for the forecast and future project convergence. So this is all about sustainable product design. So my colleague Mr. Murali, he'll be talking about sustainable manufacturing using the virtual twin in terms of recyclability or waste management, and also end-to-end visibility.
Thank you, Sri Kumar sir. As sir has said, today's world or today's planning of our product rollout or new product development or bringing our products to a sustainable and a faster rate is becoming difficult for us. So validation, visualizing and defining how much waste would come out of a process, or how much do I save with respect to my material consumption, and how eco-friendly am I with respect to all my processes. Visualizing that is a bit difficult for us on a paper basis. So that is the reason we have come with a sustainability approach which supports us on an R&D level itself, and also takes it to the design of process as well as the rolling out of the product into the market. So how would we have this journey, and what and all support we would get in this particular solution? So now I'll be showcasing a small sustainability video, so which gives us a basic glimpse of what this solution can provide. So this is how we can build a sustainable product life cycles. Out of the overall consumed plastic, only 9% of our plastic is being recycled, and according to the prediction, more than our fish, there will be a lot of plastic in our global oceans. So how do I modify this? How do I sustain, or how do I try to avoid this to happen? So we would like think to go, instead of mining, how would I utilize my resources, most available resources, and optimize the utilization of the resources, and go with the least possible way in which how I can manufacture and utilize a material for that manufacturing. So coming to our supply chains, storage, logistics, everywhere, how do we can go on a sustainable aspect is our biggest question. So coming to this, coming to the human activity, we know that a lot of thousands of supply goods and activities just to move the materials, and also while logistics, how much material, how much effluents we are producing, how much CO2 emissions are happening, and what is the distance. All these things can be visualized in our solution, and how does this being calculated will show. So we do have a database of all the processes and activities in our software. So coming to this, how and what are we having in the software? So we have a sectoral coverage of all these sectors in the market. We have agriculture and human husbandry, building and constructions, chemicals and plastics, energy, forest and wood, metals, so textiles, transportations, tourism, waste treatments and recycling, and as well as water supply. So all these sectors follow some processes in order to produce the product when it goes to a consumer. So why can't we define how much carbon emission is happening in each and every process based on a material? That is where our software comes in. So in this sector, if I am using my metal manufacturing processes, it might be aluminum drilling, turning, anodizing, brassing, casting, steel milling, or laser machining, whatever it might be. So based on the process, we have the database in such a way that if for this particular design, I'm going with this much, this particular process, this will be the carbon emission. So this will be the wastage created in this process. So which process I'll be choosing, which is much more eco-friendly. So if I have like 100 processes where the product from scratch till end to customer undergoes, so if I study each and everything, and if I have this database just to have a counter effect on what might be the process and what are the alternative methods, just to visualize and optimize as a graphical representation in the previous session where Mr. Shikumar sir has shown. So we would reduce a lot of what do you say wastage and processes on a pre-manufacturing basis itself. This is where we are defining processes. What about pre-validation of our processes, whether that is a feasible aspect or not, and how do we define the waste management? Even though I define all these processes and go with the eco-friendly materials, I am wasting my material while I'm creating samples or prototypes. How would I minimize that also? How would I not go for prototypes and visualize whether this process is viable in order to go into manufacturing that product or not? So it comes with waste management. How do we mitigate the waste management utilizing our solution? So we have a slogan called Rethink Waste Management Strategies in the Age of Circular Economy to achieve more with the less. So how do we do that? We have end-to-end visibility, life cycle assessment, and first time right manufacturing. How do I attain end-to-end visibility and as well as life cycle assessment is we have virtual tools just to create a virtual twin of our whole factory and also the processes. The 4M can be visualized utilizing that solution. No need of using any other method or no need of physical prototypes as such, so which will avoid us to create or make a product physically just to visualize whether this process is viable or not. So here is how we create a virtual twin. We can build a virtual factory utilizing our solutions. We have our library wherein which you can import your 2D drawings of your layouts. We have all the libraries of most of the materials like bins, trolleys, conveyors. Until unless it is a special purpose machine, we need not design it. We have all the assets. We have the human anthropomorphical data. You can do ergonomics. In this way, you can build your whole plant using the software itself. So here you can see how the short assembly line is being built and what and all the assets are being utilized in this particular assembly line. So I can also think of other ways how sustainable way in which I can think of making this particular assembly line, and how would I minimize the utilization of resources. I can do a multiple iterative visualization. So this is all a pick and place and easy variable solution which is used for our process visualization. After building our whole virtual factory, we can also do a hole-on-hole simulation here. So we can do a physical simulation of our process and visualize how this is going to look like. So here we are not spending any money, or here we are not utilizing any resources, or we are not wasting any kind of a material. So we would simulate and visualize whether the defined process is viable for our production or not. We would check for the design for manufacturability and producibility. We would visualize everything. Then we also do an OE calculation of a balanced line. No need of motion time study in the line. So mostly it is optimized here itself, which helps us to eliminate lots of waste. And after this, we can also connect ourselves to the VR device, and also we can have a virtual walkthrough and a virtual validations utilizing our VR capabilities. So no need of a physical setup for training or wastaging the material just to train our operators. We can use this particular solution just to train them and minimize the utilization of our unnecessary materials which will not be used for our regular production. In this way, prototype management, training management, the materials get minimized. And finally, not only this, we have a collaborative approach of all the departments, where all the departments can come in, visualize the component and decide and discuss the feasibility of production, or still they can give a lot of inputs. So here all the departments can have a collaborative approach in visualizing, discussing and minimizing the wastage of material, and also go with a sustainable approach. So these are the benefits coming with our sustainable innovation. So we ensure a long-term survivability of their businesses, grow brand value and reputation, capture existing market demand to establish short-term growth and maintain their ability. For small scale or a medium scale industries who are just making a proto and starting production for small orders, they need not do a lot of R&D just for prototyping and all. This would help them on a larger basis just to discuss on the components and bring the product into the market on a faster rate. And also we would help to maintain a leadership position in the industry as an organization that can deliver new sustainable products and services innovations to customers. So these are our customers globally. Amcor is there, Ardag Group is there, which makes lightweight water bottles. Amy's Kitchen is there, Sanfosi is there, Neo, which comes into electromobility. They are also using this particular solution globally. AMF is a group which is a FMCG. It's a consumer group which makes multiple products like bags, dresses, multiple elements like that. Nippon Shukubai, which is into the batteries manufacturing and all, they're also on a globally, they are looking on a sustainability as well as modularity, wherein which they want to reduce the unnecessary usage of material as well as alternative sustainable materials, which gives them an eco-friendly approach to the market and also their cost cuttings. So this is how we support on a larger scale with our solution in multiple markets.
So I would like to thank Mr. Shri Kumar sir and Mr. Murli for delivering a very insightful webinar today. I'm pretty confident that it was helpful to our audience as well. I would like to also thank the audience for taking their time out and joining us for this session. So if you have any further queries related to the subject matter or any other requirements, you can always connect with us. Our details are displayed on the screen right now. You can reach out to us anytime and we'll be happy to address your queries. So please do keep an eye out for our upcoming seminars and webinars. You can follow us on our social media platforms for the same. Thank you.